Dear student, today I shall discuss two more electron displacement effect, which are number one, mesomeric effect or M effect. This is also known as resonance effect or R effect, and second one is hyperconjugation. तो आज हम लोग ये दो इलेक्ट्रॉन डिस्प्लेसमेंट इफेक्ट आज डिस्कस करेंगे. इन द प्रीवियस लेक्चर हम लोग डिस्कस किए थे इंडक्टिव इफेक्ट एंड इलेक्ट्रोमैग्नेटिक इफेक्ट. सो दीज आर इलेक्ट्रॉनिक इफेक्ट्स in organic chemistry. So let us discuss one by one. So let us first discuss mesomeric effect or resonance effect. Now what is mesomeric effect? See, the permanent polarization occurs in a molecule due to interaction between two pi bond, that is called pi interaction. Polarization occurs in a molecule due to pi interaction is one type, and another polarization due to interaction between pi and p interaction. That is, permanent polarization occurs in a molecule due to pi interaction and p-pi interaction. That is, polarization occurs in a molecule due to two pi bond which are must be in conjugation or in between pi bond and a lone pair of electrons. ये क्या है? दो पाई बॉन्ड जब इंटरेक्ट करेंगे, ये दो पाई बॉन्ड कंजुगेटिव होना चाहिए, इन कंजुगेशन होना चाहिए. ये अगर दोनों पाई बॉन्ड इन कंजुगेशन, देयर विल बी इंटरेक्शन एंड पोलराइजेशन विल ऑकर इन द मॉलिक्यूल. यहाँ पे क्या है? एक पाई बॉन्ड और एक लोन पेयर ऑफ इलेक्ट्रॉन का साथ इंटरेक्शन होगा तो एक पोलराइजेशन क्रिएट होता है. सो लेट अस डिस्कस फर्स्ट वन. सो हाउ पोलराइजेशन ऑकर्स ड्यू टू pi interaction. Let us write this conjugative system: CH2 double bond CH, single bond CH, double bond CH. This is a conjugative system. There is a conjugation. Conjugation means alternate single bond, double bond, single bond, double bond. See here, double bond, single bond, double bond, single bond, double bond, single bond. This type of systems are called conjugative system. Now when this see here, we know here this is sigma bond, another is pi bond. So they all put the sigma bond and pi bond. There is a double bond, one sigma bond, another is pi bond. Now these two pi bond, there will be interaction. Suppose, see here, suppose this pi bond shifts here. Suppose here forming a bond. Now you see here how many bonds now become for this carbon atom. One, so यहाँ से आ रहा है 1, 2, 3, 4, 5 बॉन्ड हो गया. सो कार्बन को 5 बॉन्ड नहीं होगा, इसलिए क्या होगा इसमें? ये जो पाई बॉन्ड होगा, ये पाई बॉन्ड हैव टू बी शिफ्ट. देखो अभी क्या सिचुएशन हो गया. देखो यहाँ पे ये जो पाई बॉन्ड यहाँ पे आ गया. सो हम लोग क्या लिखेंगे? ए डबल हेडेड एरो. सो देखो मैं फिर से लिखता हूँ यहाँ से CH, ये ओरिजिनल बॉन्ड, न्यू बॉन्ड यहाँ पे आ गया, CH, ये सिंगल पर सिग्मा बॉन्ड पाई बॉन्ड ऊपर चला गया, CH2। तो देखो यहाँ पे एक नेगेटिव साइन हो जाएगा यहाँ पे, एंड यहाँ पे डबल बॉन्ड, यहाँ पे देखो इलेक्ट्रॉन शिफ्टेड, सो यहाँ पे पॉजिटिव साइन क्रिएट हो जाएगा, हो गया ना पोलराइजेशन। So this is the polarization occurs due to pi interaction. So this is also known as your mesomeric effect. So not only the shifting in this, you can shift like this also. You can shift like this. In that case, what will happen? This carbon will get a lone pair of electron. That is, ये pi bond हो जाएगा lone pair. ये नेगेटिव हो जाएगा, ये हो जाएगा पॉजिटिव। सो वी कैन राइट अनदर स्ट्रक्चर। एक स्ट्रक्चर लिख लिए हम लोग मूवमेंट ऐसे दिखा के, और एक स्ट्रक्चर हम लोग कैसे लिखेंगे, देखो CH2, पहले हम लोग CH2 CH डबल सिंगल बॉन्ड CH सिंगल बॉन्ड CH2 डॉटेड वन C डॉटेड वन, क्या हुआ, यहाँ पे एक नेगेटिव साइन आ गया, दिस पाई बॉन्ड, यहाँ पे एक बॉन्ड हो गया, ये कार्बन हो गया पॉजिटिव साइन। सो वी कैन राइट अनदर स्ट्रक्चर्स। So this is known as resonance also. Resonance means for a molecule we can write so many structures. That's why mesomeric effect also known as resonance effect. Resonance to write the various structures. So I shall discuss later in the next video, in the next lecture, what is resonance. And now see what is this is the polarization occurs in a molecule due to pi interaction. Now see second one, due to p-pi interaction. Means polarization occurs in a molecule due to p-pi interaction. P means lone pair of electron, pi means a pi bond. So let us take one example. So CH2 double bond CH. Say let us take a OH. This lone pair of electron, in the p orbital, these two in the p orbital, and this is a pi orbital. There is p electron, pi bond. So see, this p lone pair become a pi bond here, and this pi bond become a lone pair. So p pi interaction. Now see what will happen. क्या हो रहा है यहाँ पे देखो, CH2 negative, CH single bond, OH. Now not a single bond here, sir. Another one was already bond, another bond here comes. So this is a double bond. So this become a plus. So yeah, this is the polarization occurs due to p-pi interaction. So this is also known as mesomeric effect. So what is the definition? The permanent polarization occurs in a molecule due to pi-pi interaction between two pi bond is called pi-pi interaction, or between a pi bond and a lone pair is called p-pi interaction, is known as mesomeric effect. Like inductive effect, mesomeric effect also two types of mesomeric effect. Types of mesomeric effect. Say number one, say positive mesomeric effect, that is plus M effect, and second one of course negative mesomeric effect, also known as minus M effect. Second one is minus M effect. Now what is plus M effect? See here, in this situation here, when the displacement of electron takes place towards the carbon chain, towards the double bond, towards the conjugated system. I repeat, when displacement of electron, say here displacement of electron कहाँ पे हो रहा है, किधर कौन साइड हो रहा है, यहाँ पे ये lone pair towards the conjugative system. So this our conjugative system getting electron, so it is a positive. When transference of electron shifted from an atom or group of atom towards the conjugative system, that effect is called plus M effect. So let us take more example. Another example we can take plus M effect. So plus M effect. Say CH2 double bond CH Cl dot. So this here like this like this. See here displacement electron towards the carbon chain, that is CH2 नेगेटिव साइन, ये नेगेटिव हो गया इधर में, CH double bond Cl positive. So this is displacement of electron towards the carbon center, so it is plus M effect. So we can take in say our organic, say in case of aromatic compounds. So let us take one aromatic compound, say NH3. Here is the lone pair. Okay. So this lone pair shifted like this. Double bond NH2. See here negative sign here, shifting like this. Same this see here the lone pair towards the conjugative system, towards the carbon chain. So it is a positive. So already as it is, so this undergo again, this lone pair become here a double bond, this lone become lone pair, so it become positive because lone pair shifted, positive sign, NH2 positive, here lone, here is the negative sign. Again these are, we are writing the resonating structures. What will happen next? The NH2 plus, see here will be negative sign, so here double bond. So here see electron displacement, electron shifted towards the conjugative system, so it is a plus M effect. Now what is minus effect? Reverse of that, that is when electron shifted away from the conjugative system, away from the carbon chain. Number 2, minus M effect. What is minus M effect? When the displacement of electron takes place away from the carbon chain or away from the conjugative system is known as minus M effect. For example, say suppose take CH2 double bond CH single bond, say our CN group is a minus I affecting group, CN group bond NO2, these are minus I affecting, minus M affecting group. So C double bond N. So how electron will shift now here? So ये जो पाई बॉन्ड इधर में चला जाएगा, ये पाई बॉन्ड इधर में आ जाएगा. तो this is our group. CN is a group. So electron displaced towards the group away from the conjugative system. So what will be the structure next? CH2 double bond CH. No, now not double bond here. See double bonds. This become single one, C double CH double bond C double one N minus, and here will a plus sign. So this is the polarization occurs in a molecule due to pi interaction, and electron displace A from the carbon center. So it is a minus M effect. Let us take another example, minus M effect with the help of this one. In case of aromatic compound, say so this is nitrobenzene. So nitrobenzene can be written like this. So how, see here how the mesomeric effect occurs here, and it's a minus M effect. So here see this pi bond shifted towards the oxygen atom. As a result, see conjugation is double bond, single bond, double bond. See here come this, यहाँ पे आ जाएगा, तो यहाँ पे क्या हो जाएगा, एक पॉजिटिव साइन क्रिएट हो जाएगा, लाइक हियर यहाँ पे पॉजिटिव साइन क्रिएट हो जाएगा. तो क्या होगा इसमें, देखो नाइट्रोजन ऑक्सीजन नेगेटिव साइन, सिंगल वन. सो यहाँ पे और एक डबल लोन पे दो है ना ऑलरेडी, और एक लोन से ये नेगेटिव साइन हो गया, यहाँ तो पॉजिटिव, यहाँ पे डबल बॉन्ड, ये हो गया पॉजिटिव साइन. सो इन दिस वे वी कैन राइट, सो दिस इज, ये विल बी द पॉजिटिव साइन हियर. नाउ remaining will be as it is. So again like this. So in this way we can write more resonating structures. So this is all about mesomeric effect. So in gist, what we can say, mesomeric effect is the permanent polarization occurs in a molecule due to interaction between two pi bond, or the interaction between pi bond and a lone pair electron is called mesomeric effect. So our next displacement effect is, second one is our hyperconjugation. Hyperconjugation. See, when a alkyl group, let us write the example. So this is a CH3 is an alkyl group attached to an unsaturated system. Now this is a propane. So this is an alkyl group attached to an unsaturated system. So let us write this structural formula. Say C, this is hydrogen atom, this hydrogen atom, this hydrogen atom, CH double one CH2. See here, this is our functional group. Double bond is also a functional group. Double bond, triple bond, these are functional group. So this is a functional group. Then immediate carbon is our alpha carbon. Therefore, these hydrogens are alpha hydrogen. Now, when a alkyl group containing alpha hydrogen, alkyl, this is the alkyl group containing alpha hydrogen attached to an unsaturated system, then see this sigma electron of CH bond, the sigma electron of CH bond undergo interaction with the pi electron. So this is also known as sigma pi interaction. So when this situation occurs, when a carbon hydrogen bond attached to unsaturated system, then sigma electron of the carbon hydrogen undergo interaction with the pi bond, and a polarization occurs in the molecule, and this is called our hyperconjugation. तो क्या होगा, देखो यहाँ पे जो सिग्मा इलेक्ट्रॉन है ना, सिग्मा इलेक्ट्रॉन यहाँ पे आ जाएगा, और यहाँ पे जो पाई बॉन्ड अर्लियर यहाँ पे लोन पेयर हो जाएगा. तो हमारा स्ट्रक्चर क्या हो गया, देखो यहाँ पे H C H प्लस, यहाँ पर ऑलरेडी ये है C ऑलरेडी बॉन्ड है, न्यू बॉन्ड आ गई यहाँ पर, डबल बॉन्ड CH, ये बॉन्ड चला गया, so सिंगल बॉन्ड CH2 negative sign. So see here a polarization occurs in this molecule due to a sigma pi interaction. So this is known as hyperconjugation. Now if we take this hydrogen at this sigma carbon hydrogen, these are structures. If we take this carbon hydrogen, we can write another structures. So another structure, let us write another structure by taking this one. क्या होगा यहाँ पे H प्लस हो जाएगा, C यहाँ पे तो ऑलरेडी C हाइड्रोजन, ये है जो है दिस वन C डबल वन CH सिंगल वन CH2 नेगेटिव हो गया. So since hyperconjugation is similar to that of resonance, so if we take this one, we can write another structures. Single double one CH CH2 negative. So this is plus, this is plus. So this another one structure, this is another structure. So there are 3 alpha hydrogen. So three hyperconjugative structure. So this is hyperconjugative structure, hyperconjugative structures, hyperconjugative structures similar to that of resonance effect. But one thing here, see here, there is no definite bond between carbon and hydrogen, but still it is firmly attached with this system, uncertain system. No bond between carbon hydrogen, no bond between carbon hydrogen, no bond between carbon hydrogen. That's why this is known as no bond resonance effect. So hyperconjugation also known as no bond resonance effect. So here in this we can, in case of propane, see the propane, we can write 3 no bond resonating structures. That's why propane is more stable. For example, if you take this ethene, तो हम लोग इथिन लेंगे, तो इथिन में कोई अल्फा कार्बन नहीं है, अल्फा हाइड्रोजन नहीं है, तो यहाँ पे कोई नो बॉन्ड रेजोनेंस नहीं होगा. So ये comparatively less stable than that of propane. So in this way, by hyperconjugation, we can explain the stability of organic compounds. So we can also show hyperconjugation in methyl benzene. Say methyl benzene is, or let us write benzene first. See here, answer system, alpha carbon, alpha hydrogen. So same as that of propane. अभी क्या होगा देखो, so ये sigma electron undergo interaction, this pi bond becomes a negative sign here. क्या होगा देखो यहाँ पे, कार्बन, ये नो बॉन्ड, there is no bond, ये हाइड्रोजन, ये कार्बन हाइड्रोजन. So यहाँ पे हो जाएगा, क्या हो जाएगा, नेगेटिव साइन, ये already bond. We can write another structures by taking this one. If we take this one, क्या होगा, ये हाइड्रोजन CH H प्लस, ठीक है. So ये negative sign. Now if we take this hydrogen atom, we can write another structure. Carbon, this hydrogen, H plus, a negative sign. So these are hyperconjugative structures. See here, this compound undergo again a resonance here. This like resonance. No, not here. Here will be bond. L negative sign here. So these are hyperconjugative structures, no bond resonance structures, and these are resonating structures. In methyl benzene, see here, we can have both hyperconjugation as well as conjugation. So methyl benzene is more stable. So this is the all about our hyperconjugation. Remember, there should be a alpha carbon should be attached to a unsaturated system. So I think you have understood what is mesomeric effect and what is hyperconjugation. So there is a basic difference between inductive effect and mesomeric effect. We can distinguish. The inductive effect is a permanent polarization. Mesomeric effect also permanent polarization. But inductive effect arises due to electronegativity difference. But mesomeric effect arises due to pi-pi interaction and p-pi interaction. An inductive effect is decreases with distance, but mesomeric effect is continue so long conjugation is available. मतलब जितना conjugation हमें available होगा इतना mesomeric effect हम लोग कर सकेंगे, but inductive effect is decreases with the distance. So if you know the differences, you can understand this 4 electron displacement effect, also known as electron effects, very easily. That is inductive effect, electromeric effect, mesomeric effect, and hyperconjugation. So thank you for watching this video.